Okay, and for our last talk of the day, we have Sean, who will be giving the closing remarks, summarizing everything, future directions.
Kind of. It's,
What?
I don't know what it all means. And I actually, I started, so my step one of doing this was I took Mike's presentation and copied it and then just deleted out the stuff and changed the parts I didn't like. So I think, one, thank you guys all for coming. I'm gonna thank you now, I'm gonna thank you at the end. But just kind of my perspective, and the title got cut off. What's going on here, Noah? What's going on? Anyways, it doesn't matter. So there's different levels of organization in pathobiology, right? And I think the thing is like, what we've been talking about over the last few days is really focused on the image on the right? You look at that image, you see kind of hierarchies, you see organization, we see biology, right? But how we actually understand cellular systems, particularly if you think about immunology, hematopoiesis, cancer biology, we draw things out like this. And the reason why we draw things out like this is because it's not just about how the cells are put together physically, but it's how they're put together organizationally, right? There's parent-child relationships, there's molecular pathways that govern how they go from one place to another. There's off-ramps where cells die and do other things. And I guess really the challenge is, and what I'm hoping, and what I think I know my lab's trying to do, Mike's lab is trying to do, is to take these pretty images and start to overlay these sorts of relationships back onto these, well, maybe not onto the images, but derive these relationships out of the images, right? And so this is where we're starting to try and get at, like, how do we put cells into functional groups, both based on their, as Barbara was quoting Aviv, their intrinsic and extrinsic properties, right? Because the point is pictures are pretty, but like we need rule sets that we can actually make decisions about and generate new hypotheses. So I think a really good example of this, and unfortunately it disappeared at the top. I don't know why. I don't know what happened. No, this is what happens when you make slides the day before and you don't practice. You don't make the PIs practice. It's fine. I remember what the slide says. The slide says maybe single cells aren't enough, because this is the thing. My lab does a lot of single cell biology, but actually, the problem is believe, and I don't, I guess maybe you can't quote me on this, but maybe single cell analysis alone isn't good enough, right? And I think this was a great example, this recent study from Mike's lab, where they were trying to understand in a pre-invasive breast cancer clinical scenario, what predicts cells that go from this pre-invasive cancer to an invasive stage, because the invasive stage is where you actually need to start doing something, right? This is kind of benign right here. And long story short, they end up coming up with this. Oh, are you messing with stuff now, Noah?
Yeah, sorry. The next 10 don't have titles, but the last couple will have titles.
Perfect. Except now I can't advance anymore.
Oh, yeah, sorry.
That's all right. Oh, no, is that which one?
You just have to click, just click advance and then the clicker works again.
He's doing this on purpose.
Well, someone didn't use the slide template, so that's why.
I used Mike's slide template.
Mike also didn't use the slide template.
I don't know what to do. I'm just following. I'm following the trail that was laid out by experts before me. So they ended up finding this really cool signature that actually, from diagnostic samples of pre-invasive cancers, was able to bifurcate and almost entirely predict people that were actually going to advance to this more aggressive stage where action needs to be taken. And the important part being is that when you actually look at the top features that were driving that, all of them you could say are single cell features, but more importantly, the vast majority of those features were actually spatially defined, right? So it wasn't just about the composition of what was there, but it's where they were, what was going on around them, right? A lot of these extrinsic and like spatial factors, right? And without just knowing the cell composition alone, in absence of the structure, you wouldn't have been able to make these predictions. The other thing here, and this is again another disparaging title that hasn't shown up against single cell analysis, is this idea that, like, you know, maybe single cells aren't capturing all the information. And there was a couple questions in this session asked about things like extracellular matrix and what's going on outside the cell. What if my segmented cell isn't enough information to tell me what's going on? And so my lab's been using multiplex ion beam imaging to do a lot of studies in human neuropathology. And I just wanted to use this as an example of why just single cell data alone might not be sufficient. And so if you think about all the components of the brain, there's different ways to kind of chop up all the different cells and endothelial cells and ectodermal cells making up your network. But when you go and take all of these cells and you put them back onto the image, the thing I want to point out is, so each one of these colored objects in this kind of dentate gyrus region here, these are different objects we've segmented. But all the kind of beige in between, that's empty space. This is unannotated features, right? It's an area, it's part of the brain they call, the neuropathologists, they call it the neuropill. But the neuropill is kind of like, in my mind, it's like the ether. It's like we know it's there, but we don't know what it is. And so really, if you're doing, even though we've got this great spatial information here, if you're doing all your analysis just based on those objects, we're actually only working with a minority of the data that was collected for these images, which is kind of crazy because we spent a lot of time collecting this data. And so if you start to think about the tools that we were talking about in the workshop, and I don't think we have all the answers yet, but we can go back to these images where there is a lot of stuff in between these cells. So here's a little zoomed in view. This is a human hippocampus on the left. But if we look here in the yellow in particular, the yellow is highlighting nuclei, right? So you look, there's some areas of high cellularity, like you'd see in our nice, you know, immune tissues and lymph nodes and stuff like that. But then you've got these other layers where the nucleated cells are quite sparse, and the rest of it's this neuropil and projections. And so I think there's an opportunity to go, you know, not just use all these segmentation tools and build things up, but to use tools like Candace's Pixie, and go and actually convert every pixel in the image into some piece of information that we can start to extract and start to understand these relationships. And this is some pre-publication stuff that was done by Dunyan in our lab. But when you do that, and we go in, and this is just looking at this little tiny FOV4 here at the very top, and we go and look at a single neighborhood around one microglia. This is one brain immune cell. You can see actually how complicated the environment is that exists around these cells. And that's cool, great, it's complicated, right? But there's more, right? We can combine segmented cell information. So we can look at all of our different microglial phenotypes across this entire region, and we can order them. And when we order them and then order the Pixie neighborhoods on top of that, we can start to now derive these rule sets and relationships where we can understand what the cell looks like and what the environment it's sitting in. And I think you can look at a graph like this and all of a sudden go from a pretty picture to start to understand a structured rule set of what's going on. So that's my hope. It's my hope for the future. Maybe we can do it now. Maybe we can do more stuff like this in the future. And so just to go back to the workshop summary that Mike laid out, or the overview, and I just wanted to add my interpretation here. So these were kind of the main topics we covered in the sessions. And I just want to, you know, I think Mike said, you know, these were really two different things, but I'm going to say they're three different things because actually in general, you know, we do have, I think, a lot of the stuff on day one dealing with antibodies and titrations and selection and stuff like that. That's very spatial proteomic centric. Totally agree with you on that one, Mike. We definitely had some MIBI specific things that we talked about. But I think more importantly, a lot of the tools today, some of the stuff we talked about yesterday, obviously some of the stuff that like Barbara Engelhardt presented, these things I think are just general spatial omics tools, right? A lot of this stuff, now all the stuff in ARC's been optimized for our data formats, but I know people have used these tools or similar tools with totally different imaging modalities, even outside of spatial proteomics. And so I think a lot of the language we're talking about, a lot of the problems, whether your favorite tool is maybe or not, I think you're going to find a lot of this useful. And so this is where we're hoping we're going to nucleate some analysis strategies going to help the community in general. So importantly, Mike and I think a couple months ago, were like, we really should we should put on a workshop because a lot of people are leaving and we're gonna, we need to make sure this stuff gets organized or else they're gonna leave and no one's gonna know how to do anything. So we thought we should do the workshop, but of course, this, like everything else in the lab, we come with these ideas to do something and we don't do any of it ourselves. We particularly Mike is excellent at delegating. And so we've had the gang of people here. Most notably, you've all come to know the amenable Noah Greenwald here, who's been our MC and has really actually put the agenda together and went through all the practice talks and helped us decide what's going to be shown. And I think you may or may not have gotten this bit. I realized I didn't understand where the names of these packages came from, but actually ARC. Apparently this is the inside joke in the lab. It's actually this is Noah's swan song here to kind of put it all together. But actually, that's the Easter egg. I feel like this workshop is now going to become an extension of Noah's Ark. Also, again, thank you again for all the speakers who have who gave multiple talks and in their own goodwill organized this. The computational team who actually puts all of these packages and scripts together and answers everyone's support tickets and actually did what I think is even a harder part of presenting live. They actually recorded their talks, which I absolutely hate. It's like the worst. The worst part of the pandemic was pre-recorded talks. Hope we never have to do it again. Some of our guest speakers, thanks to IronPath for sponsoring all the non-sandwich lunches here, which was great, and for the guest speakers we have. I'm hoping in the future we're gonna expand this section of it where we have more people coming in and telling us about cool tools that they put together. And actually, the other person I wanted to thank, even though it's a little big, Mina for all her organization. So Mina actually chased people down at Stanford, found us the rooms, got some money together, found all of these lovely non-sandwich based sustenance we could all live on. And I think the last thank you, oh, sorry, actually, I was gonna say the last thank you for me, which is actually on the next slide, but whatever, I'm gonna say it now because I already mentioned it, which is I really thank everyone actually for coming. We were immensely surprised with the number of people that were interested in doing this. This was a very self-indulgent workshop to put on because we wanted to use this as an excuse to kind of get ourselves organized. But I think we ended up having over 300 people register for it. We've had a ton of people online. And I think the thing that's been most fun for me is all the questions and stuff we've gotten from people, not just live, but all the questions online. So thank you guys for that. Looking forward into the future, everything, keep an eye. I think we'll try not to spam everybody, but we'll probably send an update email out once everything's actually organized online. It'll all be hosted on the Angelo Lab website. I think this email will also solicit some feedback. So please give feedback because I think we are going to do this regularly. It was, I think, kind of painful for us collectively to put it on the first time, but I think it's going to be so much easier in coming years. And so we want to make it better. I think the other thing is that, for next year, it's going to probably move towards more spatial biology in general, hopefully more of the MIBI specific stuff. We're going to just shove over to Eric's plate and IronPath's going to take that part over, but we were just enthusiastic to share some of our own in-house workflow tools that we think have been enabling. And more importantly, I think next year, and I think we'll be soliciting some feedback for this, it can't be for 300 people, but I think we're hoping to have a bit of a hands-on component too. So particularly if you have a lab that is doing MIBI work or doing spatial proteomics work and wants to send an emissary to actually do a little kind of cooking demonstration with us over the course of these few days, I think we're going to try and have a hands-on component where you might actually be able to bake something you can eat or analyze at the end of the workshop. And with that, again, yeah, thank you guys for all coming. We're going to have just procedural stuff. We've got lunch outside. We've got tutorial office hours in the afternoon, and hopefully this is going to be a really busy one because everyone's got all the tools and it's nothing but questions and curiosity now. And then starting at 3 o'clock, if you're local in Palo Alto, I think some of us are going to be at the Rose and Crown. Noah's going to be getting, a well-deserved refreshment after all of the stress of wrangling everybody here. And yeah, I guess that's it. Thank you.